A very good day, students. So we'll continue the discussion on effect of precision and accuracy. So in the previous lecture, we have defined the concept of precision and accuracy, and the interlink between those two concepts, how precision and accuracy are determined. So we have discussed that so far. In this particular lecture, we'll be discussing about the factors that contribute to accuracy and precision of a measuring instrument, or the factors which may affect the precision and accuracy of measuring instrument. So how different things work, we can see here from this diagram. So it depends upon these four major factors. It depends upon the person. So the skill level of the measurer is a novice or a skilled labor based on that. It depends upon the measuring instrument, type of measuring instrument which we are using. So least count is a contributing factor which can determine precision and accuracy. Then environment. Which environment we are measuring depends. So we'll each discuss these topics in detail. And then the workpiece. So which type of workpiece we are measuring. So everything contributes to these four factors, majorly contribute to the precision and accuracy. The first one is environmental factors. The first one you can say coefficient of thermal expansion. So what is the coefficient of thermal expansion? So it's the ability of the material or the property of material by virtue of which it expands with increase in temperature or shrinks with decrease in temperature. So different materials react differently to temperature. For example, if you take metal, it will rapidly expand and rapidly contract with temperature. Whereas if you take a wood, it will not expand so much, comparatively it will not expand so much as that of metal, but it will still expand. If you take some plastics, they may not expand very much. Every material will tend to expand or shrink with respect to temperature, but plastic, when you compare with metal or wood, will expand less. So that's the term which is used to define the coefficient of thermal expansion, ability of the material to expand with respect to temperature. Next one is elastic property of material. So if you are measuring measuring an instrument with high elasticity, so if you are suspending the material, for example, if you take a steel ruler itself, and if you are suspending the steel ruler and keeping it for a period of time, what happens? It tends to bend. So that is due to elasticity of the steel. So such material may pose some problems when you are measuring it in a suspended position. Similarly, stability with the time. So some material tend to deteriorate with time. If you are using some unstable material or unstable compounds, then they tend to disintegrate with time. So those type of materials need to be measured quickly. Then the calibration interval. So how far the calibration interval is there? So to give you a recap, calibration is nothing but comparing with the standard instrument to determine the accuracy of the measuring instrument. So if it is calibrated recently, then you can assure that it will be more precise and accurate. So depending upon the workpiece also same properties. Coefficient of thermal and elastic property. Here cleanliness, surface finish, surface defects, etc. You have to clean the workpiece properly before measuring in order to get proper readings. The adequate datum of the workpiece. If you're having a predetermined data, previously available data, then it will be easy to compare with the data in order to check the accuracy and precision of the measuring instrument. So what are some of the properties affect the quality of the instrument? Calibration error, inadequate effect of friction, zero drift. Friction plays a major role here. Inadequate amplification. So amplification is nothing but increasing the measured value. For example, there will be very small change in voltage. But if it is a very accurate instrument, it has to show it in a larger scale. Larger scale in terms of what I'm saying is the reading should be measured by large difference so that we can understand that there is some deviation happening. Whatever small deviation is happening, the measuring instrument should display it as a larger value. Larger value is not does not necessarily mean that it should exaggerate the value, but it should show the deviation properly so that we can measure it. Factors affecting person and environment, depending upon the skill of the person, the accuracy value will change. And similarly, temperature, humidity, environmental factors play a major role. So whenever you are measuring the accuracy, whenever you are measuring using a measuring instrument, it should be done in a closed room with controlled temperature so that there is no variation in the readings. So these are some of the factors which affect the precision and accuracy. So there are environmental factors, so the properties of the workpiece, properties of measuring instrument, and also skill of the measurer. So everything contributes to the accuracy and precision of the measuring instrument. So I hope you understood the lecture on accuracy and precision. We'll meet again in another lecture. Thank you.